natural language processing. But let me just confirm. Can somebody confirm that you guys can hear me?
Yes, we can hear you.
All right, thanks. Basically, today, especially for those who have gone through the exercise that Kenny sent out, you more or less have encountered some of the things we talked about. And obviously, if you've gone through if you watched the videos and gone through the notes, you already have a heads up. But let's try and go through the slide and see what comes up. As the expectation is that as I run through these slides, if there are places where you have questions, kindly raise your hand. And I think we have a moderator who's supposed to let me know that someone has a question. The question will be thrown. If we have an answer for the question, obviously we'll tackle it. But if not, we'll also find a way of getting across and putting it on the Slack channel and finding solutions to them. So let's kick off. Okay. Natural language processing, basically, what we're trying to look at here, free text and data science. If you look at it really in the data science world, one of the things we've tried to do, data science have been very effective in taking care of, is the fact that we have a lot of text information, both in structured form and in unstructured form. For example, the comment section of maybe a product website, Twitter, for example, each of our tweets, these are texts. But also, you could also have them in some kind of structured format. Now, what we're trying to do here is to write computer programs that would try to understand what is happening within those texts. And I know that most of us are quite familiar with some of the application of NLP, at least at a very basic level. Most of us know, like the exercise sentiment, basically, or is it a positive or negative sentiment? These are obviously quite important. But what I try areas can we apply this? For example, in doing sentiment analysis, what a company could do is they monitor the sentiment of their brand online, for example, on social media, to know, okay, when is the sentiment negative and what gave rise to the negative sentiment. Is it that people are saying a lot of negative things about them? What is the root cause of this negativity? And try to nip it in the bud. That's usually one context where you could use it in the real world. You use it obviously you talk about products, brands, the basic reviews. If you know, you can now classify all the negative reviews, and then you can now analyze the negative reviews to find out, okay, what exactly are the common factors that people are talking about. You can do some kind of analysis, but these are some of the ways we can use things like this sentiment analysis exercise that Kenny sent out during the week. So these are some of the areas NLP comes to play. But you need to understand that understanding language is hard. Sometimes one of the things I found out is because it's so easy for human beings to understand, for example, even in computer vision, understanding images. Because we are so used to knowing what an image is, we think it should be easy for computers to understand, for systems to understand them as much as we do. The same thing applies to language. Language beyond, there are several contexts whereby you could use the same sentence to mean different things. So there are contexts to it. So understanding language can be a bit hard. But that said, Sometimes form of, for example, the model who was speaking now was talking about the accuracy of the model, getting like 86%. But if you add so much more data, large enough data, you might be able to do much better than that. Then, but also we will not be treating that in this class because that will involve deep learning. You easily use things like transfer learning, whereby a model has been prepared outside using a very large amount of data, so you don't have to go through that trouble. But here we'll be concentrating on some of the basic things that we can do with NLP. Now, obviously, like I said earlier on, if you look at these two sentences, you can easily say which one is positive and which one is negative. So we are trying to find a situation whereby we can use create systems that can also tell us this. Now, in doing that, you would know that one of the things you use in making your decisions about what is negative and positive is based on certain words. For example, in this case, you know that when you see words like stunning, magnificent, marvelous, you know, those are positive words. So you know that this comment is likely to be positive. Then when you see things like hollow and heartless, that denotes negative. Like Demola also said, it seems like the exercise they did, if you had a sentence that had not in it, it was likely to be negative. But here we'll be concentrating on two basic approaches, the bag of words approach and TFIDF, which is term frequency, inverse, and then we'll be working with the Ingram language models. Now, what the bag of words approach is basically says, if you have some text, you divide those texts into the individual constituents of the, for example, if you had a sentence, you divide it into the different words within the sentence. So it gives you something called the bag of words, whereby each word, then obviously when you start dealing with the term frequency, you say, okay, things like how many times does a particular word occur in this particular the particular text we are working with. But let's just go ahead. And so before we start, let's just look at what some basic terminologies we use in NLP, so that when we continue in the class, you understand what we're trying to say. Okay, for example, when we talk about a document could be a sentence. So a document, you should not look at documents in the context of the normal way we look at documents. Maybe you say a Microsoft Word document, not necessarily. A document in the context of NLP is just a group of free text. For example, one tweet is a document. One comment, a comment in the product section of the website is a document itself, because it's different from every other comment. And words and terms refer to the individual words. Basically, remember when we talked about, I just spoke about bag of words. The individual words that make up the documents are, you could call them words or you call them terms. They are also what we could refer to as, in a way, tokens. They are separated by white space. That means this word space, then there's another word. So that's what. Then a corpus is basically a collection of documents. If you have large, maybe 1 million different tweets, 1,000 different books, or 1,000 different PDFs, as the case may be, but a collection of different corpus. Now, in doing the bag of words, I know many of us have seen things like this, these word clouds. They are quite interesting to do this. They are fun. But what it basically does is it counts A bag of words just basically a reference. So basically what you are saying is you count, you look at, you convert, or if you get a document, let's say you get a PDF of maybe a chapter of a book, and then you analyze it, you split it such that you have the bag of words, the individual words that make up the document. Then you do a count of the most prominent words within that document, and then you visualize it. That's basically what a bag of words, basically what a bag of words represent. You're trying to look at what are the most prominent words within the document we are dealing with, or within the corpus we are dealing with. And you can easily represent it using something like this. And there's a code for it, which we'll look at when we get to the code section. Now, the goal of this lecture is to just explain the basic free text processing. Now, as you can see, this example, these are 3 sentences. Let's take this as the corpus we're working with, where there are 3 different documents. 1, 2, 3. Now, we can look at them. If you do a bag of words for it, you can see that the reason why you have 2 in our x11, x being our matrix, the reason you have 2 in x11 is that it represents the first document. We have D occurring twice at the beginning and just before basics. That's appearing twice, which is after goal and after basic. That's why you have it this way. So this is like counting the individual words. So this first row represents this first document, the second row as that's how it works. So this is basically, this is a term frequency matrix, whereby you've looked at all the words and you have calculated how many times each word appears. Now, there are different ways that term frequencies could be used. It could be a case of where you are, one we just did now, we basically counted how many times the word appears. But in other instances, you could use it in such a way whereby you don't deal with repetition. Appears or doesn't appear. So in that case, what we will have is something like this, but you only have ones and zeros. These 2 will not appear. In these places where we have 2, just have 1 because it appears. There's an off in this. Is there an off in this statement? Yes, 1. If there's no off, 0. That's basically what you're working with there. Now, but in some cases also you could also do a log of it. But these are basic different representation of it, but they are basically doing the same thing, because in the absolute, they look like different value, but if you look at them relatively, they are still the same thing. So you can also do it in a way whereby you normalize them. That's using those words divided by the max to get some kind of normalization. So that's, but just understand that they are all called term frequencies, whether you are doing it as a binary or you're doing it with where you normalize by dividing by the maximum you have within the document. They are all term frequencies. Now, what we're trying to do here is, okay, let's look at it this way. We're trying to say, have here, this matrix is basically the term frequency up here. But for the case of inverse term frequency, for example, if you look at this particular instance where we have 2, what we'll have here of, okay, let's look at, you'll find out that D in the first document, with respect to the first document, what you have for D here will be 3/2. Not for the first for this particular thing, if you are dealing with D will be 3/2. because D applies in comes up in 2 of the documents out of the 3. So the 3 at the top represents the number of documents you're dealing with, while the figure below represents how many different documents it applies in. So as you can see, for off, in all 3 documents, that's why you have 3/3. While is applies in shows up in only 2, which is the first and the second. That's why it's 3/2. Then it gives you, then you take a log of that to get the inverse document frequency. That's how you basically get that. Now, the reason we do this is you would notice that words such as D, is, and off, which are not really, if you're looking at a document, the words that are more likely to be relevant to what that document means are not likely to be the words that appear too often. It might be just the words that appear sparingly. So in order to take, for example, when we look at, let me just go through something. When we're looking at sentiment earlier on, there were certain words earlier on. There are certain words that were highlighted earlier on. Let me see if I can find them. That's okay. There are certain words like stunning, magnificent, marvelous, hollow, but that give us the true context of what we are dealing with in that particular document. Now, if we use only the term frequency, we will be giving more weight to words that appear more regularly, like D, but they don't really give us the meaning of what we are dealing with. So in using this inverse document frequency, we are giving more weight to words that apply less frequently. As you can see, the words that apply once within the documents has a higher IDF, inverse document frequency, because if you take a log of it, it gives you a higher value than the words that apply more often. If you look at it really, you will see it helps to create more or less balance and give more weight the words that don't appear so frequently, but that might actually be more relevant to the meaning of the documents. But usually in normal cases, what you find is you now work with the term frequencies and the inverse document frequency. You multiply them together to work with, because it's a more it works much more better when using that than when using the individual cases on their own. Now, at all this, we've only looked at the words, the individual words within documents, but also we could have a situation whereby we want to look at the similarities of 2 different documents. If we look at it from the standpoint of, let's look at sentiment analysis, for example. If 2 different documents, for example, 2 different comments were made for a particular product, we want to see how similar are they. We can look at the similarity in terms of, are they more similar in terms that they are more positive, or are they more negative? We can look at it from that point of view. So if we have a large number, we could look at them as segments. Some are more different segments that helps us to look at, these are negative tweets or negative comments, and these other ones are positive because of the similarity. You use what you call a cosine similarity. Now, the cosine similarity is not really something complex. It's basically doing some linear algebra where you just, if you want to compare the similarities between 2 different documents, by then you would have already maybe done either your term frequency. So you've gotten the vectors using term frequency, or you've gotten the vectors using the TFIDF, which is a term frequency inverse document frequency. You could use either to compute the similarities. Now you just take a transpose of the first document and do a product of it with the second document to get what is above. Then obviously you normalize, whereby you sum and do you square each value within the vector of the first document, and some kind of Pythagoras where you square all of them, add them together, and do the square root, get a particular value for the first document, get that same thing for the second document, multiply them together, and then use it to normalize what you have at the top. That's basically what this formula means. If we do it for the document we've been working with, these three, we'll get something like this, where you see that the diagonals represent self, like this first point, you are comparing document 1 with document 1, so they are perfectly aligned, so they are the same. It's going to be 1. Then this second the first, I'm dealing with the first row now. You find out that 0.068 is really the similarity between document 1 and document 2. Why 0.071 and document 3? And you can also see that 0.1, that's dealing with the second row now, the third value in the second row, you have 0.103. That is dealing with the similarity between document 2 and document 3. As you can see, these words, they're basically 4 different numbers we have here, which is dealing with the particular document with itself and dealing with the documents with others. But now, using this similarity cosine similarity, there's a downside to it, in that if you don't remove what we call stop words are words that are naturally recurring, D, is, or context of what we are dealing with in most cases. If you do not drop them, you'll find a situation whereby 2 documents will be said to be very similar to the other, because, for example, if you look at it now, you can see that document 1 and 2, okay, that document 1, 2, and 3 have a high similarity, which is 0.103. Now, the main reason is, you could easily look at it, is, okay, sorry, between 2 and 3. Okay, this might not totally explain it. This one where there's a better explanation for why this might occur. Now, hold on, please. Looking at similarities, if you use the stop words D and they occur, for example, if you have a particular document and 2 different documents, and you have things like is, D, off appearing consistently within the documents, it will show, and you don't drop those stop words. If you do the cosine similarity to show that those 2 documents are quite similar compared to another. But really, if you're looking at the documents, let me see if I can find the example. Okay, this example. If you look at these 3 documents, Pittsburgh has some excellent new restaurants. Boston is a city with great cuisine. Then Postgre is a relational database management system. Ordinarily, you looking at it will say that these first 2 documents, which is our first 2 documents here, are more similar to each other, in that they are talking about good food within in cities, where the cities here are Pittsburgh and Boston, and great cuisine talks about food within Boston. Pittsburgh also talks about excellent new restaurants, which also refers to food within a city. But this one totally is talking about something totally different. But if you do the cosine similarity between them, you would notice that the highest similarities will happen between the second and the third document, mainly because of this word is and a appearing in both of them. They are going to be stamped as more similar. But if you were to drop the stop, you are likely to see that these two are more similar. Obviously, that's when we have a whole lot of documents, not within this small documents. But that's why sometimes the cosine similarities will not function very well if you don't drop stop words. Now, but later on, we'll look at something like word embeddings. These are more advanced ways of looking at NLP. They are more advanced NLP formats, mainly in deep learning. But I think we'll look through it later on in the, as we go on. Now, there are also other situations. Now, if you look at something like this, a boring movie are not great, and great movie are not boring. They have the same words, exactly the same words, but they are two different words. One is negative and one is positive. But if you use the normal ways, the normal term frequency and TFIDF that will be using, this will be perfectly the same, but they mean two totally different things. So if you were to use this, create a model using those two TFIDF to determine whether they are negative or positive, they are going to be termed as the same thing, both of these words, which is why the need for doing things like language models. Now, in talking about language models, we could use something like a probabilistic language model. What this deals with is the probability that if you have a set of words, for example, let's look at the example given here. Say and extract insight and knowledge from large amount of. So what is now you're trying to find out the probability that the next word will be either data or hot dog. Now, ordinarily, you looking at it will know that this is basically talking, because you know about data science, you know that the next word will be data. Now, the way you use in making that estimate is because of the information before that data. Now, in a probabilistic sense, what you're trying to calculate is that the probability that the word that will appear here is greater for data than for hot dog. And how you do that is by doing things like the Ingram model. What this does is it looks at, for example, let's just deal with a where we are. N-gram means the number of n basically is just a placeholder that represents number of words before what we want to create a probability for. Now let's look at just two, where we are dealing with two being the words, two words before the word we are trying to predict. There's some kind of an example later on. Okay. Okay, now let's use this example to just explain it. The goal of this lecture is to explain the basics of free text processing. Now, if we were to say that we wanted to find we wanted to use this to check the probability that of words that come after off, what you will find is that if we go through this entire document, off appeared twice. So what will eventually happen is that this and free will have a probability of 1/2, in that in two actual cases where off appeared in the document, in the two actual cases where off appeared in the document, one of the words that came after it is this, and the other word that came after it, this will have a probability of 1/2, while every other word will have a probability of 0. That's basically what the the estimating probability. That's the basic probability we use within this context. Obviously, when you're talking about higher order Ingram models, maybe 4 or 5, they are off, and I want to predict the next word that will come up for each places where I see off. I will take it that this will have a probability of 1/2, and free text using this document obviously will have a probability of half, while others will have a probability of 0. Now, what happens in Laplace smoothing is that it doesn't make sense to do a situation whereby we'll have a probability, like in this case now, every other thing here will be 0. So using it in a different context where these two don't appear, it will mean that it
Hello, guys. Can you all hear me? Okay, so I think we lost Ike.
Yes.
So I think we lost Ike, right? He said, I just called him and said he's having to think power issue, but he's trying to come back up, right? So while we wait for him, okay, let me, I don't know whether I should take the opportunity to probably go up over the, yeah. Okay, so like I said, the idea was for everyone to get a feel of what or see how everything they've been learning in the past can be put into practice, right? So like I said, what I wanted you guys to do in this particular line of code, right, is to import the document. So in this case, it's a review.txt file that's located in a folder in the document I sent to you guys, and then a labels.txt file. So for it, what it means is that this reviews.txt contains different reviews by different people, and then these labels, right, is the corresponding is a corresponding label for each of the review. And you're having two labels here. You're having the positive and the negative. So it's either a review is positive or a review is negative, right? So, but now this code here kind of separates the different documents that are in this text file by reading the lines and then performing some lambda functions, right? So what it does is that it separates each of the reviews into a list, right? So you're going to be having a list of reviews. So you can look at it as your document, like I said before. And then the same thing goes here. You're having a list of all the labels, right? So is it positive? Is it negative? So it means that for every index, say let's say index 50 on the reviews, the corresponding label for that particular review at index 50 would be index 50 on this labels list, right? So here I wanted you guys to, I think this is already a solution to one of the things I told you guys to do. So, but here I wanted you guys to show, print the length of the reviews, right? I wanted you guys to show the first review. So if this is showing the 10th review, then you should be able to do, write an operation to show the first review. And then I wanted you guys to show the length of the labels. And of course, you would find out that the length of the labels will be the length of the reviews, right? And then I wanted you all to show the unique labels, right? So that's that. And I hope this should be actually very easy for everyone, right? So now here we just print. Here we are just printing the labels and the reviews to see what it looks like. So you don't actually have to do anything here. All you just need to do is write, run the codes. But I wanted you guys to explain how it works, right? It doesn't need to be something very much, just a very simple description of what this particular function here is doing, so that you understand what you're doing, right? Now we are going to be doing some operations. At this point, we did some operations that are similar to what you would have learned in the IX class, right? Here, some of you might be asking why we used the counter function in this collections library instead of the normal dictionaries. Some of you would have also figured out why we used the counter function. The reason why we use the counter function is because there are some inner functions in this counter function that we would want to use, right? I think someone sent a message. Which would want to use, right? Oh, sorry, someone just corrected me. Yeah, I'm so sorry. So reviews, this is not the 10th review. Thank God some people found out too. This is not the 10th review. This is the 11th review. Since Python starts from 0. Made that mistake, right? So to find the first review, of course, you still know what to do, right? So like I was saying, thank you, Toib, for that, even though he sent the message privately. So we would want to use the counter function because there are some things that the counter function does, which it will be kind of difficult to achieve with your normal dictionaries, right? And here we created we instantiated three counter objects, right? The positive count, the negative count, and the total count. And the idea is that we want to have a dictionary, yeah, of the words that occurred in the positive reviews, right, as the keys here, and then the values will be the number of times those words occurred, right? Same thing here, similarly here, we are saying we want to have a dictionary that contains all the words that were found in the negative reviews, right? And the corresponding count for each of the words that were found. But here, the total count, we want to have all the words, be it the words in a positive review or negative review. We want to have all the words in both of them in one dictionary, and the count of those words in both the positive and the negative review, right? So this should be very simple. I actually should have made you guys do this, but I didn't want to put too much stress, but it's something that everyone should be able to understand. So this function actually achieves what we want to do, what I explained over here, right? And then now you'll see where the counter objects or the counter function gets very interesting. So now if you run this, right? Positive dot most count, positive underscore counts dot most count. It will return the counts that occurred more than the other. So it will start with the words that occurred, the words that had more frequency, and then to reduce gradually. Same thing with the negative count, right? And then when we do the total counts dot most common, we show the common counts for both the negative and positive reviews, right? That's the common count in the whole corpus, right? So let me stop here and see if we have any questions. If you have any questions, just please signify by raising up your hand. No questions, yeah? Okay. Okay, someone has a question. Okay, you can speak.
Yeah. The most common, is it like a function we have to define, or is it something that comes with the import counter that we did at the beginning of the?
Okay, so like I just said, that it's something that comes with the counter function, right? You don't need to define anything, right? It comes with it. So you just positive counts dot most counts, right? Someone else raised up his hand. Okay. Okay, you can speak.
Yeah, I wanted to ask the same question that.
Can't hear you.
Hello, can you hear me?
Yeah, I can hear you now.
Yeah, I wanted to ask the same question that Babatunde just had, and it was verified, so it's fine.
Okay, okay, thanks. Aziz and Lukman, okay. Aziz
Yeah,
first.
okay. Okay, so my question is, at the beginning of this exercise or assignment, you gave us the reviews and then you gave us the labels. That's telling us which ones are positive and which ones are negative. Say, for example, in actual practice, you have a list of data and you want to check which one is positive and which one is negative. Do we actually have to, import from, say, something you already know? I don't know how to explain. Like, say you want to review for a particular company. Yeah, do you have to go over each and every one to see which one is positive, negative before you actually write the code, or you cannot just infer from this one?
Okay. Aziz, you are going too fast. So we are getting there. But I'm actually happy that you're already trying to figure out some things in your head. So you are already tending towards machine learning, and machine learning is starting soon. But I'll answer your question, right? So the idea is this. So there's something you call supervised learning, and there's something you call unsupervised learning, right? In supervised learning, you are training your model, right, with data that has labels, right? So these labels are things that you have. So let's say it's questions you have answered, right? So like in this case now, this is a supervised learning, right? You have reviews. You have, if you're going to make it a supervised learning, you have to go through the reviews and label them as positive or negative. So now, what this means is that in machine learning, what it means is that you are getting previous data, right? You are labeling this previous data, and you are using this previous data to train a model that will be able to predict for future occurrences, right? So it's not, you are not, in machine learning is not something where you write a code to make a prediction, right? And then tomorrow, if somebody something changes. You write another, maybe you write another code to make another. It's not a code thing. The model learns based on some features that it's seen in the data. I don't know if you get what I'm trying to say. So like you said, if it's a supervised learning, you have to label your data set. You have to label your data set. If not, it's more or less like you are kind of taking your model by the hand and telling it that, hey, for this particular feature, or for this particular feature, this is the right label, or this is the right prediction. Try as much as possible to make this prediction. Try as much as possible to make this prediction here, in case you see future data that you have not seen before. I don't know if it's clear, Aziz. Aziz, you can speak.
So much. Okay, yeah, I get that. So I'll just wait till machine learning then.
Okay.
Thank you.
Okay. Yeah. Then Lukman raised up his hand. Lukman Adeoti.
Thank you. Actually, I figured out the solutions to my questions. So I'm retracting my raised hand. Thank you.
Okay, nice. Thanks. So let's move on, right? Okay. So where did I stop? I stopped here, right? So now, at this point, you guys would remember something around the 10th frequency inverse frequency that Ike talked about here. So something similar happens here. So the truth is that you can approach any problem in natural language processing in any way you want to, right? So for those of us who looked at this and couldn't understand, yeah, look at it as a way of, look at it as you're trying to find a way of, okay, let me start this way. You know, you have words, right? I think I should go back to, sorry. Let me go back to Ike's notebook. This slide, I think it's somewhere here, yeah. Okay. Right. Okay, so at this point, right, you'd remember that the professor said something like, we can often very easily tell the overall gist of natural language text without understanding the sentences at all, right? So now what it's trying to say is that, yes, this is a whole lot of words, right? But you can get an overall gist of what this whole word is saying, yeah? Not by reading all through the word, but by identifying some particular words in this whole sentence, right? So in this case, you're seeing words like stunning, magnificent, marvelous, right? So these words kind of give us an overall gist of what this whole sentence is trying to say, right? Same thing with this word here. So it's telling us, oh, this is either pointing towards a positive or negative review. And that is what we were trying to do in this particular place, right? We are trying to analyze the data set we have. We want to kind of say, okay, which words are the words that are tending towards the positive review? Which words are the words that are tending towards the negative review? You would agree with me that it's very possible that you find a lot of words that are in that. So now remember, we created these dictionaries, and these dictionaries contains a lot of words, and the negative dictionary contains a lot of words, right? So now it's very possible that most of the words you find in this positive count dictionary will be the same number of words you find in this negative count dictionary. But you would get a sense of of how positive a word is based on the frequency of that word compared to its frequency in the negative count, right? Let me repeat myself. You get a sense of how positive a word is based on the ratio of the positive count of that word or the positive frequency of that word in the positive dictionary to that of the frequency in the negative dictionary, right? And that's basically what we are trying to do here. So here we are saying, okay, right, we know all the words, all the unique words are in this dictionary, right? And we can loop through this dictionary and get the word and the count. So it's more or less like saying you're getting the word, the key, and the value, right? And now we are putting a ratio here, right? That if a word is common, right? If it has been used more than at least 100 times, right? So we are putting a threshold to tell us that, oh, if this word is frequently used, and there's something significant about this word, we should explore this word more to know whether this is something that is usually found in positive reviews. But mind you, words like is, I, it are also words that can be very, very, very frequent, right? So we also have to find a way of identifying the words that are irrelevant, right? In your word vector, right? So now we place a threshold that if the word is greater than 100, right, we want to explore it further, right? So now we are saying we want to find the ratio of that particular term. Now we remember we are looping, right? We want to find the ratio of the particular word, right? The count of the particular word. So when you do this, it's actually the count you get. So we want to find the ratio of the count of that particular word to the count of the one in the negative, right? And now, like, I've forgotten the name. Ademola said, right? We are adding the one in case we have 0 in this negative column to as much as possible reduce errors, right? So now, when we get the ratio, we are saving this ratio in this dictionary or this counter that we have created above, right? So now this would contain the ratios of all the words. So now all the relevant words that's words that have a count greater than 100, right? So this dictionary will contain all those words and this ratio that we have defined here, right? So I want to ask a question. Everyone, you can answer by maybe just putting a message on the chat, right? So my question is this: the length of this dictionary, between the length of this dictionary and this dictionary, which is greater? So we can answer using the chat, right? I'll just give us 3 minutes.
Mic check. Please, can you repeat the question?
Okay, so I said the length of the words or the length of this particular dictionary, between the length of this particular dictionary, total underscore counts, and this dictionary, positive underscore negative underscore ratios, right? Which of them is greater? Okay, I'm actually happy. Nobody got it wrong. That's great. Okay, so let's continue. Thank you very much, guys. I'm happy. Okay, so so after this, you can just print the ratios and then see how it works. So now you would see what the ratio of D would be, what the ratio of amazing would be, what the ratio of terrible would be. And you'll notice something, right? Words that tend to be positive, right? Or which have a great, let me use the word great positivity, right? You'll find out that they tend to be greater than 1. So they tend that they try as much as possible to be farther than 1, right? And then words that are negative, they try as much as possible to be closer to 0, right? On the other hand, you find out that words like the is I will always tend to be closer to 1, right? And what this means is that if you've read the text carefully, what this basically means is that these words are neutral. So they occur almost at the same frequency in both your negative and your positive review, right? And sometimes, not always, right? Sometimes depending on what the researcher wants to do. Most times you find that these neutral words, you can actually remove it from your data set, all right? But like I said, it depends on what the researcher is trying to achieve from the whole experiment, right? Excuse me, just give me. Okay, sorry about that. Okay, so let's continue. So you would find out something from this whole experiment. You find out that the deviation between the positive review, negative review, and the neutral review can be sometimes very, let me use the words, the variance can be very, very scattered. You might get confused to how close a particular review is to being, or how you might get confused on the rate of positivity of a particular word. So a way of kind of scaling this down to reasonable values is by applying logarithms, right? And that is what we did here. So if you run this code here, it finds the logarithm of each of the ratios that we have calculated in this code cell above, right? And it calculates it, and then you find out here that there's a kind of switch. The negative reviews tend to be closer to 0. No, rather, the neutral reviews tend to be closer to 0, right? The negative reviews are negative, right? And the positive reviews are positive. They are usually greater than 0. They tend to be far greater than 0. The negative reviews tend to be far lesser than 0. And the neutral reviews go around the value of 0, right? And with this, we can actually print to see the positive, the most common positive reviews and the most common negative reviews, right? So this gives us everything, right? But it's from the positive downwards, because you know the positive values, the positive reviews are the ones that have the positive ratios, but the negative reviews have the negative ratios. So it will start from the positives. But if you want to see the negative, you can just simply do a reverse of this particular dictionary here, right? So I'll stop again to collect questions, to take questions. So if you have a question, just signify by raising up your hand. Questions. I'll continue in the next 1 minute. Okay, Jamie has a question. You can speak, Jamie.
Okay. Sorry. My question is, we've been doing NLP. Are you saying NLP is totally different from machine learning and deep learning? Or which under category can you actually classify NLP under these two?
Okay. So, like I said, I'm happy that everyone's imaginations are beginning to get open and all that, right? So natural language processing is just an aspect of machine learning, right? It's an aspect of it's an area in is it in machine learning or deep learning? Let me correct you now, even though I'll still say it again in future. Deep learning is a subset of machine learning, right? Deep learning is a subset of machine learning. So like I said earlier, or let me use the word deep learning is a method of machine learning, not a subset. Let me not use the word subset this time. It's a method of machine learning. But natural language processing is an area where you apply machine learning, right? Is it clear?
Yeah.
Okay. So, yeah. So, but we'll still talk about all this as we go, as we move on, right? In the next class, I will introduce you guys to okay, I could introduce you guys to machine learning, and then some things will get clearer, right? Okay. Any more questions? Okay, so we can move on. So we are here, right? So now the idea of everything here is to prepare your data to feed it into into your model, whatever model you have created. So I didn't want any of you to go through the stress of understanding the complexity yet. I didn't want you guys to go through the stress of understanding the complexity of why I'm doing things this way. I just wanted you guys to see how this data are preprocessed here, and how whatever you do in this, whatever Python function or whatever idea you put into these particular cells here can help you train your model at this particular point here. So here, I just wanted you to create a set of the total count of words in your the total counts dictionary. Yeah. So what I mean is this: you know, you have your total counts dictionary that we have defined above, which contains the total count of all the words, right? So it's a dictionary containing the keys of all the words in that part, in all the documents, and then the corresponding counts, right? So now this is creating a set of just the keys. You get? So it's invariably what you're saying is you want to have a set that has only the unique words in the whole document, right? So that's what we did. I wanted you all to do here. And then I wanted you to print out the size to know what's the number of unique words, what the size of the unique words look like. And if your print is not equal to this value here, that is 4,074, it means that there's an error somewhere, right? Then down here, of course, we have been working with NumPy, so you should be able to do this. I wanted you to create a NumPy array, so but a vector this time around that contains zeros. So these zeros should be of dimension 1 by 74074, right? So you want to have a vector that has 74,074 zeros in it here. And yeah, when you print it, it should display this, right? Then over here, right? I want you to take, so now remember this, this particular action here has put all your words in I think it's a list, a set, yeah, it's a list, right? Let's put all your words in a list, right? So, but here I want you to give, now you know this list here, each position of the words in the list, we can see it as an index, right? So now I want us to have this index as the values in a dictionary. So that's what I meant here by the word to index, right? So you're saying for each word, what is the index? So you can just pick the index that you have here and attribute it to the words, right? So you can say for the first word that you have here, the index is 0. The second word index is 1. The third word index is 2. I don't know if you get what I'm trying to say, though, but you're having a dictionary that maps the words to their index, right? And then you can print it here. Okay, someone has raised his hand. Okay, you can speak. Ademola, you can speak.
Okay, can you hear me?
Yeah, we can hear you.
Okay, all right. What I wanted to ask is, now this word to index. Now, if you remember, when in the vocab, we have already put it in a set. And what I understand about set is that it doesn't arrange it in a particular way. So the word to index here would not be the index that will be assigned to the word would not be exactly the index that was in the view test. So
Sorry, I didn't get you. I didn't get it clear.
Now, what I'm asking is, this particular word to index that we're supposed to write a code for, that we're supposed to create here. Now, is it the word, the index that we want to be attached to the word? Is it as it were in the review text? Because if we use the vocab that we earlier created, it was in a set. And for set, every time you print vocab, I noticed that it's rearranging it. You know, for sets, it doesn't have to be in a particular order. So the index will be reassigned for each word every time that you print. So that's why I wanted to ask if we are expected to just run it with the vocab or write a code that would assign the index as it were in the review text.
Okay, so I'll try to. So if I get it clearly, you are saying you're asking whether we should write a code to assign probably unique indexes to your vocab, right? Because you've probably noticed that maybe each time you run this code, the index of your the index that you get for each of the words kind of changes, right? So, but well, what I can say is that you don't actually need to write any special code to generate indexes, if that is what you're trying to say. Remember that when you do perform a function to create a set out of your that's here, right? To create a set out of this total counts dictionary, right? You save it in a variable. That variable does not change the positions of the words, right? It doesn't change it. So now if it's saved in a list, right, it doesn't change the positions of the words in the list. Now, if you take that particular variable that has a list, the list of all the words stored in it, right, and then you pick enumerate, right, when you enumerate through that particular list to get the index and the word, right, you can create a dictionary named word to index, where the key is the word and the value is the index that you are getting from your enumerate function, from your enumerate operation. Is it clear? Jamie, I can see, but I need to be sure Ademola is clear. Is it clear, Ademola?
Yeah, I understand now.
Okay.
Thank you.
So Jamie, okay, you can speak, Jamie.
Sorry, what I actually inferred from this question is, up there we've declared our vocab to be sets. Okay. So, and he's saying the peculiarity of set is it doesn't have an order. It changes each time it's not like list that has a permanent index.
Mm-hmm.
So each time you iterate to get the index, you always have different index attached to each word.
So, but let me. Okay. Well, I have actually not experienced that. Maybe I didn't try, but like I said before, if you're saving it in a variable, I don't expect it to change, right? Except if you're rerunning this over and over again. So maybe I'll try out what you're saying, but I don't expect it to change because I've gone through this code. I actually completed this code. Okay, someone is raising up his hand, but let me just complete what I'm saying. When you save your set into this vocab, right? Except you are rerunning this again, your vocab should have words that are in positions that shouldn't be changing, right? And that is what you would use here. I'm sorry, here, right? So, okay, Zen is raising up his hand again. Okay, let me start with Ademola. Ademola, speak.
Mic check.
Yep.
Yes, I think I get to what they're trying to say. I think what you don't understand is the word index is a dictionary, right? So you are creating a new dictionary whereby the first item in the set will be the first key. It have a value of 0. The second item in the set will be the second key in word to index and have a value of 1, just like that, down to the end of the set. I can share my screen to show you a code snippet for more clarity, if you don't mind.
Thank you, Ademola. I really want you to share, but let me just round up. And then, yeah. Someone else raised up his hand. Sorry, I forgot the name. But you can speak if you raised up your hand.
Yeah. Ademola has answered what I was trying to ask.
Okay, thanks. Okay, so we can move on, right? So by the time you have your words to index, right? The idea is this. So I'll go a bit high level with what I'm going to say now. The idea is this. Somewhere around here, you're performing a function that you would, okay, not here, right? Okay, somewhere here. Here, was it here? No, not here. I think somewhere here, you are performing a function. I'm using a function here that will be used in my model. So the idea is this. I'll just go over this particular area. You don't really need to go through it. The idea is this. So now you have changed your words to an index sort of, right? So when you're training your machine learning model, for this particular project, it's actually a neural network that I used. I think a two hidden layer neural network, right? So, but there are different ways you can feed in your data into the model, right? For sentiment prediction. The non-advised method is feeding in the frequencies, right, of the words of a word in a particular document to make a prediction. Yeah, but the best way is actually to feed in the possibility that a word occurs in your vector or not. So let me try and explain this. I'll use an illustration here. Right? So now let's say this is our so let's say this is our NumPy array that contains a lot of zeros, right? So this is our NumPy array, and this particular array corresponds to what we have created here, right? So now the idea is this. The index of each of these zeros would correspond to what we have in this word index, right? So now it is this NumPy array of zeros, not that's in this, it's something of this form that you are passing into your neural network, right? But you are passing it such that if a word occurs in a particular document, wherever that word is, or wherever the index of that word is here, you would replace the zeros in that particular index here with a 1. So now let's say index 0 content is good. That's in our NumPy array, or in our words to index dictionary. Index 0 means good. That's index. Let's say index 0 means good, right? Index 3 means bad. Index 4 means D, right? So now, if we are passing a particular document through the model, right, either to train the model or to make predictions, wherever that particular word is, wherever the index is in this particular NumPy array we have created, wherever that word is, would replace it with a 1. So now, if the particular document has a word called D, you would replace it with a 1 here, right? And the particular word contains, sorry, I said good here, right? So if the word contains good, we'll have 1 here. If it contains D, we'll have a 1 here, and so on and so forth. So this will kind of give your model, your neural network, a sense of, is this word a positive word, or is this word a negative word, to help it in predicting whether it's a positive or negative word. And that is the exact method that was used in making and in building this particular model, right? But for this particular one, yeah, some modifications were made. So I would use the word complex modifications were made. Complex modifications that we'll learn later were made to make this train better. And you'll notice that if you make predictions on this, right, on this particular model above here, you find out that it performs not so correctly, right? Most especially when the length of your review is short. So it's most likely not getting a good sense of how well, a good sense of what you're trying to say. So, but if you have a review that it's very long, right, it will tend to predict it better. But on the other hand, this one actually performs pretty better than the one above. But these methods Yeah, it works for this particular data set, but there are better models that have been developed to make predictions make predictions on larger data sets and have better predictions. And these are deep learning models, basically, using some more complex algorithms. So do we have any other question? Do we have questions, right? Let me take questions before I move on. Any questions? Okay, it's very interesting. There's no question at the end. Please, any question whatsoever, I will answer you. Okay, no question. So I remember Dinma and one other person raised up his hand, raised up their hands, yeah, that they had issues while going through the assignments. So are you still having that issue, Dinma? And I can't remember the other person's name. Forgive me, please. You can speak if you're one of those.
Okay, I don't have that issue anymore. Thank you. Actually, one of my questions was regards what somebody asked, the values changing when you run it again, it keeps changing. So I had an issue with that as well. But since you've explained, I'll just go back to it after the class. Then I've forgotten the other question I had, but I'll get back to, I would look at it again. And then if I still have that challenge after your explanation, maybe I'll just contact someone on Slack. But right now, I think I'm fine.
Okay, interesting. Thank you. Is there any other person that has any question? So is it safe for me to say that everyone that is on this call can complete the assignments before tomorrow, right? Or is it safe to say that when I send out the links for submission, that I would get encouraging responses? Okay, Fatima has a question. Yeah, you can speak, Fatima.
Okay, hello.
Yeah, hello. How are you doing?
Okay, under the at that point where we have x equals to input and MLP.predict x, each time I run that line, my code just go silent. It doesn't bring any feedback, and then I observe that it's just there. I can't run any other code further down.
Okay, let me ask a question, some questions though. First things first, is it, did you try restarting your kernel when you noticed this?
I restarted severally. And each time I restart and start from the beginning, I get up to the point where I train the model, and it trains, and it gives me up to 99.9% that it finished the training.
Okay. Oh, okay. Now I think I get where the issue is coming from. Okay, so now when you run this particular code, right? This MLP does predict. So this predicts, yeah, is a function I wrote. What you expected to do is you are supposed it will display a box beneath for you to
Yes, it did.
input.
It did.
Yeah.
And
Did you input something?
Yes, I just typed something like bad, good, and then
did you press enter?
Enter. No, I just clicked run.
No. So you should press enter.
Oh.
So that's not a code cell. That's an input cell. So you should press enter. Yeah.
Okay.
Yeah.
Thank you.
Yeah. Okay. Any more questions? Any more questions, guys? Okay. So I think that's it for. Okay, someone raised their hands. Okay, Genevieve, you can speak.
Okay,
Genevieve.
hi, Kenneth.
Okay, the reason why I'm not talking is that I didn't actually go through the rest. Where I stopped was where I stopped. So not like I checked and saw maybe any complication. You understand? I'm
Yeah.
not actually paid attention. My system was low when I was doing it. So where the battery stopped was where I stopped. So that's why I don't know if there's any complication. Then when you were explaining, my network was bad. So I was going off and on. So I didn't want to draw the whole class back. So I felt,
Back.
let me first go through it before I know if I have any complication.
Okay. Okay. So, but what you can also do is maybe when we are done with class,
Recording.
yeah, exactly. So you can
Yeah.
just go through the recording and then make use of Slack. But
Yes,
I'm sure it's something you can do. Trust me. Yeah.
Yeah, thanks.
Okay. Someone said extended. Ademola, I'm not really sure what you mean. Okay, so unfortunately, Ike might not be able to join. I don't know whether I don't think he'll be able to join anytime soon because I think he's having serious power issues. But going through what he has taught you guys or what he's teaching you guys, I don't think it's anything that we all cannot go through on our own, most especially after the explanation I've given on this particular. Genevieve has raised up her hand. So, but let me just round up what I'm saying. So, most especially after the explanations I've given on this particular sentiment prediction exercise. Yeah. But let me answer Genevieve first. Okay, Genevieve.
Okay, thank you. I was waiting for I to finish before I asked my question. Then I'm not looking at my system, but there was a part that had, I think it was the IDF that had the log reading part.
Okay.
The calculation there, the log 3/2. When I watched the video and I did it, it didn't give me the answer. The man had 0.4 something, but when I did log 3/2, I got 0.176. Then the other one, log 3/3, the man had 1 point something. When I did mine, it didn't give me exact. But the only one I did that corresponded with what the man had was log 3/3. So that's log 1, which is 0. So I don't know if it's a mistake or there's another calculation we missed out, or I missed out rather. Do you get?
Yeah, I kind of get. Even though
I think
I
it's
didn't.
supposed to be natural log.
Yeah, I did. We did it in our group too. We did log 3/3. We had the same 0 he got. Then we did log 3/2, which is still log 1.5. But I didn't get the same answer he got. In the video, I think he said something like 0.48 log 3/2. I did the same. We did the same thing. We didn't get his answer. So we're wondering if it was a mistake or we missed out something.
I think it's a mistake. I think it's a mistake in it because I'm trying it out now, and then it's not giving. It's a mistake in it. I think I experienced the same thing. It's a mistake on his part. That's on the professor's part. Yeah. So it's not. I don't think it's from us. I don't think it's from you. Right?
Okay, thank you.
Yeah. So, like I was saying, through what I wouldn't to see the compensate for this period that he has missed out, right? So aside that, other issues I would want to discuss with everyone is next week. If you check the curriculum, you find out that okay, Teji, you want to say something?
Yeah, I got cut off, so I wanted to make sure that I'm not repeating something someone else already answered.
Oh, okay, you can
Regard
speak.
to the logarithm.
Oh, okay, you can speak.
I was asking that isn't it supposed to be natural logarithm? Can you go back to the slide, please?
Okay. That's ln, yeah?
Yeah. So
I
log
didn't even
3
try that.
is 2, right? So it's supposed, let me, I'm checking it right now. 3 divided by 2. So it's actually natural logarithm, which is ln.
Okay, that's true. It's ln. ln.
Can you try that and confirm?
Yeah, it's true. You're right. It's ln. You're right.
So everyone, log base 10 is natural logarithm, but on your calculator is ln. It's ln, not log. So the log on your calculator is log base 2, I think, if I'm not wrong. But if you want to have this, what is having here, you should do ln, or on the web, you can just do log to base 10. Then you should be able to get this.
So, and then something else, you'll notice, guys, here that in his example, right, he's using natural log. So one thing you should understand that most times, whatever you decide to use is based on what works best for you, right? You'll notice that in our simple practice, we didn't use natural logarithm here, right? We used just the normal log. Where is it? Here. So here we just use the normal log, right? So it still depends on how you want to see your
Are you
data.
sure that is normal log, or that's
Yeah,
natural?
I think it's normal log. I think it's normal log, not natural.
Are you sure?
Let's confirm. I don't have. I can't print out my
Log is natural logarithms. So I just
seriously. That means I didn't know that. So I'm just knowing that if that is true, but I'll confirm though.
Addition though.
I'll confirm it. Okay, so that aside, we are learning every day. Where was I? Okay, so it's natural logarithm. Seriously.
NumPy.log it's the natural log.
Actually never confirmed that too.
Yeah. Usually when they use log, it's for things like this, it's natural log in most of the frameworks or anything. So.
Okay, so that's fine. Thank you, Teju. So back to what I was saying, yeah. If you check the curriculum, you find out that there is no class for next week, right? So in essence, what it means is that next week we have a break and we'll be resuming the upper week, right? So it's a break from class, right? Not a break from learning. So we should take the opportunity to, as usual, revise everything we have learned. And then hopefully I'll be posting articles that will more or less introduce you all to the application of machine learning, right? Before we go into how to build machine learning models for the class that we'll be having in the upper week. And like I was saying before, for the class that IK has missed, right, I will discuss with him on how he can organize a session to complete what he left off. Probably on Slack or maybe on Zoom, if everyone will be available. Yeah. So I think that's all for now. I don't know if Teju has anything to say.
Not much. Thanks, Kelechi. That was an excellent tutorial. I just wanted to say that, you know what, guys, do something for me. Go through the slides, and if anything is unclear, and you've gotten to a point whereby you're like, oh, this statement is unclear or something, just drop me a chat or something. send it to me and then we'll look over the slide together. But like Kenichi said, it's something you can go through and understand. But I'm also, I also understand that sometimes some of this, it depends on how familiar you are with some of the terms, but you need to go over the lectures yourself. So yeah, I'm just giving you myself. If you go over it today, and you have any question, send me a DM on Slack to ask me any question.